Lecture 8.2, Day 1, Vectors in the Plane. This is a view of the Cliff Palace ruin in Mesa Verde National Park, Colorado. Warning: only some of this is review. Quantities that we measure that have magnitude but not direction are called scalars. Quantities such as force, displacement, or velocity that have direction as well as magnitude are represented by directed line segments. Here's a directed line segment from A to B. We have an initial point and a terminal point. We write it like this. The length is the magnitude of AB. A vector is represented by a directed line segment. Vectors are equal if they have the same length and direction, or same slope. A vector is in standard position if the initial point is at the origin. The component form of this vector is v equals v1, v2. The magnitude or length of v equals v1, v2 is the absolute value of v, or magnitude of v, which equals radical v1 squared plus v2 squared. Here we have a vector from -3, 4 to -5, 2. The component form of vector PQ is v equals -2, -2. That is, -2 in the x direction, -2 in the y direction. The magnitude is radical -2 squared plus -2 squared, or radical 8, which is 2 radical 2. If the magnitude of the vector equals 1, then v is a unit vector. 0, 0 is the zero vector and has no direction. Vector operations. Let u equal vector u1, u2, v equals vector v1, v2, and k be a scalar or real number. U plus v is equal to vector u1, u2 plus v1, v2, which is equal to vector u1 plus v1, u2 plus v2. In other words, we add the components. For subtraction u minus v, we just subtract the components. So we subtract the x components and the y components. Scalar multiplication, k times u, is like the distributive property. We have k times u1 and k times u2, or k times the x component and k times the y component. negatives or opposites, as in -1u, just gives us the opposite of the components. If we line up vectors end to end, no matter which one we add first, they combine to be u plus v, which is the resultant vector. This is known as the parallelogram law of addition, because we can arrange the vectors in a parallelogram to find the resultant vector. The angle between two vectors is given by theta equals inverse cosine u1v1 plus u2v2 over the magnitude of u times the magnitude of v. This comes from the law of cosines. The proof is in your book if you're interested. The dot product, also called inner product, is defined as u dot v equals the magnitude of u times the magnitude of v times the cosine of theta, theta being the angle between the vectors, or u1 v1 plus u2 v2. That is, we multiply the x components and multiply the y components and add them together. We read this u dot v. For example, vector 3, 4 dot vector 5, 2 is 3 times 5 plus 4 times 2, or 23. Notice that our answer is not a vector. This could be substituted in the formula for the angle between vectors, or solved for theta to give theta equals inverse cosine u dot v over the magnitude of u times the magnitude of v. Example, find the angle between the vectors u and v, where u is vector 2, 3, and v is vector -2, 5. Using the formula, we have theta equals inverse cosine u dot v over the magnitude of u times the magnitude of v, which is inverse cosine of vector 2, 3 dot vector -2, 5 over the magnitude of vector 2, 3 times the magnitude of vector -2, 5, which becomes the inverse cosine of 11 over radical 13 times radical 29, which when we plug into our calculator, we get about 55.5 degrees. And notice that I did this one in degrees, not radians. So if you want a degree answer, you have to put your calculator in degree mode. Here's an application. A Boeing 787 airplane flying due east at 500 miles per hour in still air encounters a 70 mile per hour tailwind acting in the direction of 60 degrees north of east. The airplane holds its compass heading due east, but because of the wind, acquires a new ground speed and direction. What are they? We can draw our vectors. First, the vector for the airplane, which is due east at 500 miles per hour. And then the vector for the wind, which is 60 degrees north of east at 70 miles per hour. Notice that this drawing is not to scale. We need to find the magnitude and direction of the resultant vector u plus v. Using the parallelogram law of vector addition, we see the resultant vector u plus v. The component forms of u and v are u equals vector 500, 0, that is 500 in the x direction, 0 in the y direction. V equals 70 cosine 60 degrees, 70 sine 60 degrees. Or, since cosine 60 is 1/2, V equals 35, 35 radical 3, since sine 60 is radical 3 over 2. Therefore, u plus v equals 535 and 35 radical 3. The magnitude of u plus v is the square root of 535 squared plus 35 radical 3 squared, or 538.4 approximately. And theta equals the inverse tangent of 35 radical 3 over 535, which is approximately 6.5 degrees. The new ground speed of the airplane is about 538.4 miles per hour, and its new direction is about 6.5 degrees north of east.